Hello everyone. This is our sixth example of solving using the Pythagorean trigonometric identity. We're doing many examples here because we want to ensure that our viewers should be able to work out such kind of problems on their own without having to memorize the same. So I recommend that you watch all the six examples and you'll be able to do these kind of problems on your own. Now we'll have to prove that 1 by cosecant A minus cot A minus 1 by sin A is equal to 1 by sin A minus 1 by cosecant A plus cot A. So let's see how we prove this left hand side is equal to this right hand side. So let's consider the left hand side first. We have 1 by cosecant A minus cot A. So what is the one which connects cosecant and cot? So like similarly we did such problems and we used this identity called the Pythagorean trigonometric identity. Sin squared theta plus cos squared theta is equal to 1, and we need a relationship between cosecant and cot. So how do we obtain cot? Cos by sin is equal to cot, isn't it? The trigonometric ratio cotangent is cos by sin. So let's divide both sides of this equation by sin squared theta. So that the value of the equation is not altered, we are dividing both the sides. So what do we have now? We have 1 plus cot squared theta is equal to cosecant squared theta, and now we have obtained a relationship and we can manipulate this in any manner. So suppose you want to subtract both sides by 1, you get cot squared theta is equal to cosecant squared theta minus 1, or if we subtract both sides by cosecant squared theta, we get cot squared theta minus cosecant squared theta, right? Am I right? Yeah. I'm subtracting this side by cosecant squared theta. So I think I'm not right, yeah. But of course, here also I would get something. That cot squared theta minus cosecant squared theta is equal to something. But suppose I am subtracting cosecant squared theta minus cot squared theta. What do I get? I get this is equal to 1. And now let's use all these three and let's try to prove what we have initially. So this is what we have. Now we need cosecant squared and cot squared. We just have cosecant and cot. So in our previous example also we learnt a method to do this. We multiply the denominator by its conjugate. What is conjugate? This is cosecant A minus cot A. The conjugate would be cosecant A plus cot A. The main idea is to use this algebraic identity A minus B into A plus B. This would be equal to A squared minus B squared, and this is how we bring in the square of cosecant and cot in this expression. So let's take the left hand side and start multiplying. 1 by cosecant A minus cot A. Its conjugate would be cosecant A plus cot A, but you cannot just divide the denominator and leave it because the value of this expression would change. So the numerator is also multiplied by cosecant A plus cot A, and don't forget the minus 1 by sin A. This is our left hand side. Now what has happened? We have in the denominator, we can apply this algebraic identity and get cosecant squared A minus cot squared A. Now this should ring a bell, otherwise of course we can go to the next page and check. And the numerator has cosecant A plus cot A minus 1 by sin A. And now what is this denominator equal to? It's equal to 1, right? So the whole expression becomes cosecant A plus cot A by 1 minus 1 by sin A. Now this being 1, this denominator being 1, let us find the LCM of both so that we can add or subtract both these expressions. The LCM is of course sin A. So let's multiply sin A into cosecant A plus cot A. So I'll write it sine A into cosecant A plus cot A, and the denominator is, of course, it is 1 here. But now we make the denominator common because we have multiplied this by sine A by sine A, right? What does it mean when we have found the LCM? Multiplied this by sine A by sine A. So this denominator would be sine A minus 1 by sine A, and now of course we can write it together because the denominators are the same. So let me extend this and write minus 1, right? And so what do you have now? The numerator sine A into cosecant A is nothing but sine A into 1 by sine A, because cosecant A is the reciprocal of sine. So what is sine A into 1 by sine A? It is 1. And then you have sine A into cot A. And what is cot A? So let me write one more step by simplifying. So sine A into, you have cos A by sine A, right? Minus 1. And the whole thing is divided by sine A, right? I suggest, or I strictly say, that use a paper and pen and work it out along with me. So this sine A and sine A gets cancelled, and this 1 minus 1 is 0. So what is that which we have ultimately now? We just have cos A by sine A. This is equal to cos A by sine A, which is equal to the cotangent of A, cot A. So we have proved that the left hand side is equal to cot A. The whole thing, this is equal to cot A. Now let's see what we can do with the right hand side. 1 by sine A minus 1 by cosecant A plus cot A. We can do the same thing, multiply cosecant A plus cot A by its conjugate. So let me rewrite 1 by sine A minus 1 by cosecant A plus cot A. I hope I am right. I'll just check once. 1 by, yes, the same thing. So this is equal to, let me multiply only this by its conjugate, just like what we did before. I think now you will be able to do it on your own. So I'll go a little faster. We are multiplying both numerator and denominator by the same expression. And what do we have? We have 1 by sine A minus cosecant A minus cot A, and the denominator is cosecant A plus B into A minus B, which is A squared minus B squared, and you know that cosecant squared A minus cot squared A is equal to 1, and this is what we used in our earlier left hand side also. And now once again multiply this by sine A by sine A, because we need an LCM, so that we add both these or subtract both these expressions. So what do you get ultimately? I'm sorry, I've written cos A here. You multiply both numerator and denominator by the same expression so that the value is unaltered. So sine A by sine A. So this thing is equal to 1 minus sine A into cosecant A minus cot A. Of course, I'm coming here. I'll write it neatly in my next line. So this is by sine A, right? So let's simplify this numerator. 1 minus sine A into cosecant A. It gets cancelled, isn't it? Because cosecant A is 1 by sine A. So this is equal to 1. And what is cot A? You have actually minus sine A cot A. Or is it minus? No, it is not, because minus into minus gives you plus sine A cot A. But cot A can be written as cos A by sine A, right? Cos A by sine A. And once again, the sine A both numerator and denominator can be divided by sine A. And what do we get? 1 minus 1 is 0. So we just get cos A in the numerator, but don't forget the denominator, it's sine A. Right? Sorry, this thing is, yeah, the whole thing is divided by sine A. Let's not forget this. And this is equal to cot A again. Now we have proved that the right hand side is also equal to cot A. Now let's just check our initial expressions, the equation which we started with. This is also equal to cot A. The left hand side and the right hand side are equal to one another. I hope you followed the problem. It is not enough if you just watch it. Please work it out so that you understand it better. Thank you.